Hello, dear colleagues. Welcome to our presentation on RE 2020. The subject is PCl titanium dioxide and a composite to improve aging of the offset prints. And my name is Tomislav Hudika. I'm assistant researcher at the University of Zagreb, Faculty of Graphic Arts, and I'll be presenting on behalf of my fellow colleagues. So this is a short summary of the subject that we will go through. The cardboard packaging has a vast share in packaging industry, regardless of the general opinion. The packaging, which is supposed to grow in the period of 2018 2020 up to 3.1% annually. The industries are faced with new trends such as eco-friendly and green industry development, and packaging, of course, is no exception. To improve properties of the biomaterial, one usually adds some chemical compounds. Recently, nanomaterials are widely used in the composition of these materials. And the aim of research is to characterize the cardboard packaging, which is coated with PCl titanium dioxide nanocomposite, and then artificially aged. The PCl titanium dioxide nanocomposite should lower degradation of prints, aka ink fading, when exposed to UV radiation of general sunlight. So the ink fading is a phenomenon that is not something that one would like to see on the printed subject. Experiment. Two common paper types were used, uncoated offset paper Sepitauro and UPM finesse gloss paper. Both are used in packaging materials, all in caliber of 300 grams. Every piece or overprint varnishes were prepared by dissolving PCl in acetate and then adding different mass concentration 0.1, 25, and 0.5 of titanium dioxide. The samples were printed with offset SMIC on a sheet fed printing machine in compliance with the ESA solution were prepared with magnetic sphere in airtight container, then dispersing the nanoparticles with the ultrasound disperser. The OVP was applied with the coating bar 3. And after drying and characterization, the varnish samples were placed in the UV chamber, then artificially aged, and the samples were subjected to either exposure or the test chamber was divided into intervals of 2 up to 5 hours. So in table 1, one can see that ink density generally decreasing for all 4 inks when decreasing the weight ratio of Titan 1 in the coating. Decrease of density values is largest on black, which is achromatic color, and lowest on cyan, as the titanium dioxide is a white powder and it decreases the reflection of the light from surface and therefore causing a decrease of ink film density on a subject. So observing figures, one can see that ink density change of cyan and black are almost none. All magenta and yellow could be seen in decreasing trend of density change over accelerated aging period. Ink density on the uncoated paper. So ink density on the uncoated subject is lower from 1 pound or less. As mentioned before, fading as phenomena can be explained as the change in ink density measured by reflectiveness, which in this case the surface property is very low and the subject itself is matte. So ink density on cyan and magenta. Cyan and magenta are presented through the entire tested accelerated aging period. The density change of cyan is increasing. For example, the ink is lowering the density values, but in very small amount, regardless of the application of nanocomposite coating. And the magenta result do show that ink is decreasing. density faster than one observed on cyan. The biggest density decay has occurred on the original yellow sample of uncoated paper, and the most stable one in this experiment was black. When we're talking about colorimetrics, the figures are presented in this table, and you can see that all the printed inks on the original, so before coating, are compliant with the FOBRA PSO. But magenta is very close to the allowed tolerances. So allowed tolerance is the delta AAB5 under 5, and red figures are the ones that that lack the designated delta E norm. So chroma change of cyan and magenta. So the chroma of magenta ink is stable regardless of the accelerated aging time and the composite used. On the other hand, on cyan and yellow ink, it is clearly seen that it decreases it decreases the chroma within the duration of accelerating aging process. Although it was suspected that black ink without protection would get lighter, results show rather the opposite. The L coordinate is decreasing during the accelerated aging process. This change is low and is close to the instrument's reflectability, but one could see that trend could be noticed. Colorimetric analysis on the uncoated paper. So it can be seen that all printed inks on the original four coatings are in compliance with the PSO norm. Moreover, the titanium dioxide coating did lower the delta EAB on magenta, yellow, and black, which is because PCL coating itself lowers lightness of colors. Chroma change of cyan and magenta. So I can see that cyan had very low change in chroma during the tested measurement. If the chroma change is lower than 1, it means that chroma sample has increased, and if the change is higher, that means the chroma sample is lower than the one on the beginning. The magenta and yellow increased chroma, with yellow being less affected with nanocomposite coating. Example, chroma change of all yellow samples are similar to the 10 hours of accelerated aging. So the yellow and magenta inks are predominantly chromatic coordinates in the LFA color space, with magenta dominant in A+, and yellow being dominant in B+. Of course, although it was suspected that only the black ink without protection would get lighter, results show also rather the opposite. All measured results are scattered throughout the diagram, meaning that titanium dioxide was probably soaked in the spot thread, as there is no visual trend. So print gloss analysis on coated paper. So print gloss, of course, is important visual aspect when measured to see the dependence of the light due to the accelerated aging process. So it can be noted that gloss is widely affected by the weight ratio of titanium dioxide. The uncoated cyan printed sample, for example, has 71.1 gloss units at the beginning, while the values go down in almost linear decrease with increase of weight ratio of titanium dioxide. So accelerated aging impacts the overall print loss of uncoated samples The most while samples protected by nanocomposite deteriorate less. When we're talking about yellow and black, so yellow and black are the one on yellow and black one can see the similar behavior within the composite, lowering the initial loss or stabilizing it throughout the entire aging interval. On uncoated paper, the situation is rather different. According to the ISO norm 2813, all measured values under 10 are considered to be met, while over 3 glass units difference, under matte surface is visible to human eye. So basically, this change was not visible to the human eye. Same goes with yellow and black. So the change on all measured inks are barely visible and therefore relevant on the macro scale. So to conclude, accelerated aging caused significant change in optical density of yellow inks on both papers, while cyan and blacks experienced almost no change in optical density. Nanocomposite proved their role in preserving inks, which is more visible on coated papers. The increase of weight ratio of titanium dioxide improves the protective effect, which can be clearly seen on coated paper and a bit less, of course, on the uncoated paper. The nanocomposite do not cause colors to go outside the allowed tolerances on the uncoated paper, but shift the magenta outside the tolerance on the coated paper. But you have to keep in mind that magenta was very close to the tolerance. Similar to the optical density, chroma of the yellow ink uncoated decreases the most in the aging process. Results of the print gloss determination show that print gloss decreases by coating with nanocomposite, but in the aging process, all the concentration of titanium dioxide stabilize the print gloss to the initial values after coating process. So results of the print gloss determination show that print gloss decreases with the coating application, but in the aging process, all concentration of titanium dioxide do stabilize the print gloss on the initial values after printing process. And one more thing, it is rather to change on, of course, all the measured uncoated papers regardless to the print gloss are once again barely visible and relevant on the macro scale because they're not they cannot be seen or noticed with without the human eye. So we have to thank the Croatian Science Foundation for supporting our project. Thank you, everybody, for listening. For all questions, suggestions, you could email me, and then maybe we could continue the discussion over email. So stay safe and very best hellos from Zagreb. Thank you. Bye.